the way it's parsed is parsed by the standard differs from the way it's parsed by the browser. So here's the way it's serialized. You have the HTTP shim, and then this is how the browsers are parsing it. They treat this as a mistype, typing error, and they use the 3 slashes as the separator between shim and host, and then they use this as a host name, the path separator, and the tag. And the real way you have to do it is declare the host name as null, and then use the next slash as a host path separator. So the reason that this worked was because the host name was null, so it was inferred that it was a how do you say? A relative link, but it was not a relative link because browsers parse things differently. So there are more problems. This is another problem with PHP. So people usually use PHP self, environmental variable, to link to the file that you are on. So people usually do something like this in forms or in redirects. And well, if you go to hostname / www.google.com and you encode the slash, etc.
So the example here is with an href, but I mean, we're creating this and thinking, in terms of redirects, that this exact same syntax could be used instead of an anchor tag for some sort of redirect. Yeah. Yeah.
So well, that when you're doing this, the // is parsed as a it's parsing as a complete URL that is relative to the same shim that you are, but it's making reference to the hostname. So well, that links to http google.com, even if you're using PHP self. So that's something that people usually do. And then that links to there. So well. How to parse URLs correctly? Now, it's very difficult because browsers don't do it correctly in general at all. And I'm going to present some examples about why it's very difficult to do it correctly. So you have to guess which one is the top level domain. So it can be facebook.com or google.com or yahoo.com. So the correct answer is it depends on which browser you're using and which version of which browser you're using. So yeah. So actually the correct answer here in Firefox is google.com because the Unicode character 12,290 is full width dot, and the 65,295 character in Unicode means a slash in full width slash in Unicode. So in order to parse URL correctly, you have to be Unicode aware, and that's kind of difficult. Here, what is the hostname? This is a very difficult way to. So you have to check that there is only one slash. The fact that it only has one slash makes it a relative URL. So it depends on which website you are. So if this website is in http:/google.example.com, then it will point to example.com/google.com.
So it would be a relative URL in this case.
Yeah. And then if the URL is loaded in an SSL website in HTTPS, it will point to http://www.google.com. The reason it is because in the RFC, it's not very well defined what to do in these cases. So some browsers do that, and some browsers don't. And the problem is that it makes, well, the RFC actually says it's an interesting case that every implementer has to consider, but it doesn't say how to solve it. In this case, which domain will be loaded? So this is actually a very interesting vulnerability in Flash. But anyways, the website that is going to be loaded is going to be google.com. However, Firefox and some other URI parsers are going to ignore everything that goes after a colon. The colon is usually used for separating the hostname from the port. However, if it's not a normal, so you can put HTTP instead of paypal.com, and it will assume it is the port 80 because there are something that is called resolving port names. Anyways, the idea is that you can use a port name at the port number or name after the colon.
So one interesting thing with that is when you're dealing with like blacklisting filters for malware or things, there's lots of websites and services that do that. And at least up until a year ago, in some browsers, you could just add arbitrary text into that port field and it would be ignored. So you could have google.com : and then and then some random text, and whether you had the port there or not, it didn't matter because it would default to port 80. And so if some URL that an attacker had was being blacklisted, he could easily bypass any blacklisting filters just by adding some random characters in there because these browsers would ignore them. And the browsers in question have since fixed, Firefox has fixed it at least. So things like that are an issue. But it's just interesting to know that how some of these can be abused directly by attackers in really simple ways.
Yep. So it was fixed in 3.5 or 3.6, and well, Opera still works like all the time. And other browsers give you an error, especially I don't remember. Safari sends you to an error page. That's even better. So URL parsings. Alexations we found have been because there's a judgment call that developers, implementers have to do when they are implementing this type of behavior. And well, one of the problems is that it's kind of difficult to know when the URLs represent a relative link or an absolute link, even when they are well-parsed URLs. So well, people will tell you there are rules, but the RFC HTML size data, the rules are in the RFC 1808. And well, actually, the RFC is kind of ambiguous. So there are a lot of implementation differences. So, so you have to take in mind that search engines do have open redirects, that some login sites have open redirects, and some OpenID customer providers have open redirects. And given that OpenID is supposed to end up being used as a centralized authorization and identification, blah, 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 you have to consider that it may be vulnerable, lots of websites. Some of them are not vulnerable, like FriendFeed and stuff.
Like with OpenID, it depends on the implementer. Many are vulnerable, some aren't. Just depends on the actual implementation.
So the conclusion about URL parsing is about you shouldn't trust hostname-based whitelists, and unless you are completely sure they don't have open redirects, but then you are also assuming that they are not vulnerable to well, it's a shame. Check how your URL parser behaves on several browsers. So java.net.url is a good example. Like the example I showed at the beginning, it's a very good example of why java.net.url is doing it wrong. Redirects are a main component of HTTP functionality, and we won't take them away. However, we should be careful on how we do it, how we use them. And the only reason they are dangerous is because people forget about them, developers and users, right? So reminder, URLs are evil. Even if you check that the URL you are loading is ponies.com, and you are going to fetch that result and serve it back to the user, it may redirect to a file URI, and you may be actually sending back to the user private information. And URLs don't represent a resource. They are uniform, even if they say they are in the name. So they can be known as unfortunate redirect launchers, whatever. So we had to remove some slides. All right.
OK, so there's a few other issues that we want to cover real quickly here with URL shorteners. So this is kind of a bit of a rant. I apologize if that offends anyone. But so URL shorteners are terribly common nowadays, and they're pretty evil in my mind. But it's hard to say that they're the new buffer overflow. They're certainly not that. But the way I think of it, it's like bad hygiene. It's like being accustomed to not washing your hands or something. Yeah, it's not every day you're going to get pwned by it, but it's still just bad hygiene. So perhaps a better example that I could come up with is this. So when I was younger, I grew up in Utah in the United States, and it's the home of the Rocky Mountains, and I'd like to go hiking in the mountains there. And since they're the Rocky Mountains, there's a lot of rocks there. And for whatever reason, as a kid, I thought it'd be really fun to go hopping from rock to rock. And so I would just like jump along and try not to ever touch the actual ground, but actually would just jump from rock to rock. And I thought that was, just made it extra challenging and exciting as I was hiking in the mountains. And it was great and fun and all, and I even fancied myself as having a really good eye for picking out good rocks to jump on and which ones to land on, because usually these aren't terribly big rocks and they're on trails on steep mountains, and some of them could easily fall out of place. Well, obviously at some point I did jump on a rock that fell out of place and ended up hurting myself really bad and hurting my leg really bad, and it really sucked because I'm injured, but not only am I injured now, but I'm 3,000 meters up in the mountain or whatever. Like it just wasn't a great place to be. So, in hindsight, I think it's really obvious to think, well, it was risky behavior I was engaging in. I should have, just, been more sensible and, just stayed on where firm grounding is, where the firm ground is. And I think it's kind of similar here with URL shorteners, and that it's just kind of unnecessarily risky behavior that we're conditioning ourselves to be accustomed to. So let's just look at a couple examples. So this is an open redirect. This is like a normal benign site that's and an attacker is trying to redirect somebody to their malicious website, their malicious file. So now, granted, a lot of people who see this URL would still click on it and become a victim, but a lot of people would see this and think, that's kind of strange that evil websites are in the URL, and they might not. I mean, there are some clues there to cue the person off. So you say, well, what if it's encoded? Well, okay, so that's harder to tell that it's going to evilwebsite.com, but even though that's in effect what it's doing. But still, seeing a URL like that still might be enough to clue some users into not clicking that. I mean, it's obviously harder to tell that there's malicious things going in there, but just the fact that there's a lot of URL encoded stuff would be weird. So what about this link? How many people have clicked on a link like this in the last week, or in the last day, or has posted a link on Twitter in the last day that's like this? Yes, some came from me. That's entirely true. I'm completely hypocritical here. I apologize. So yes, we all do it. I mean, these links are very common. So, and there's nothing there to clue you off. That's 36LNJ2A could be a completely normal site, and if it ended with 2B instead of 2A, that could be a completely malicious site. There's no clues to tell you that this is bad. So that's kind of the theory. What about real life? Would this type of thing really happen in attack? Well, yes, it did. It happened 2 months ago, and it's actually a really neat story. I'll go through real quickly here. So there was a post that was posted on April 5th in 2010. Somebody posted on Apache's Jira tracker a tinyurl.com link that was just like this. I don't know the actual URL because the Jira blog didn't include it, but it was, and the message itself just said this: I've got this error while browsing some projects in Jira. Okay, so an administrator comes along and sees this message and thinks, okay, there's some user who's having a problem. I'll click the link to see what the problem is, right? It's very logical. Well, so they click the link and it turns out to be malicious. What happened? So, well, first off, it was a cross-site scripting, a zero-day cross-site scripting in Jira that was attacking Apache's own Jira servers. So I don't know the details of that, but I'm assuming it was covert enough that the administrator who clicked on it wasn't clued in right away what was going on, because it took a few days for this whole thing to be detected. So what happened with the cross-site scripting? Well, that along with brute forcing somehow led to the Jira being compromised. So to be fair, it wasn't ever clear which of these two it was. I'd put my money on the cross-site scripting with the tiny URL, but officially it could be either one. So going from there, the attacker disabled notifications in Jira, and then was able to change the upload paths where files were uploaded to be a place where they had write permission to upload JSP files that would be executed, which gave them access to users' home directories and a backdoor access on the machine to have not root level access, but normal level access, whatever user Jira was running as. That allowed them to install a jar file that began collecting logins and passwords for users. That led to them eventually getting an administrative password for the server, so now they had root access on the box that was running Jira. That allowed them to start collecting SVN passwords on the box that were cached that gave them access to another server. So at the end of that, they had, just as they were starting to compromise this other box that had more sensitive Apache information on it, it was all discovered and everything was closed down, and Apache did a great job, cleaning things up and disclosing what had happened. So, but all of that, if you think, just stems back to a cross-site scripting attack. But in my mind, it actually was one step before that. The tiny URL. If it hadn't been encoded, or the true destination hadn't been hidden with a tinyurl.com link, I'm guessing the administrator probably would have been smart enough to think, hey, that looks kind of suspicious. I mean, I'm just speculating, but I think you understand what the point I'm trying to make here is. So the question is, can URL shorteners be made more secure? Well, can you do some sort of blacklisting with them? No, that's just, if you think about it, that's never going to work. What about whitelisting? It's certainly better than blacklisting, but still going to be very difficult to do. What about if a URL shortener service Well, so outside of the URL shortener service, one thing you can do as a user to become more secure is to use something like the request policy Firefox extension, which will prompt on every single redirect by default.